Hey there, welcome back to the channel. My name is Chris, and today we're going to have some fun with a servo and an analog joystick. When we move the joystick, we rotate the servo. Let's go take a look at the code and how this is set up. First, let's talk about how we've got the hardware wired up. I have an analog input joystick here. This has an X and a Y analog. Basically, it's just a voltage divider. So we're feeding it 3.3 volts and a ground, and then the voltage from the X or the Y come back into our analog inputs. Here on the Grove connector, this is I2C and power. This comes over to a PCA 9685 servo controller. Really, it's a PWM generator. It can run up to 16 channels. We just have one hooked up. And I have this angular servo hooked up here. It's 270 degrees full range of motion. The thing that makes it at least somewhat interesting is rather than simply a digital, we're moving to the right, swing it all the way to the right. Since it's an analog, if I move it just part of the way, you can see I have the color brightness here is really reflective of how far it's turned. So if we push it just a little bit, we have a dark cyan, and if you look at the servo, it's moving in proportion to that. So it's a proportional movement rather than a full one direction or full the other. Let's go take a look at the code for how this works. I did a previous video on how the analog joystick works and how we do all of the drawing to the screen. I'm not going to go over that again. I'll put a link up in the corner. What's important here is if we take a look at the initialization, again, we've got the display service that displays that plus on the screen, and we have an input service which is watching the joystick. What we've added to the application is this servo service. The servo service, really all we do is we create it here in our initialize of our app, and we pass in the I2C bus, which is what we're communicating it with. Once I have that wired up, the only thing that I'm really concerned with is the X direction movement on the joystick. So we have an X value changed. Before we were sending that to the display service so that it could update the display. We're also going to send that into the service. For the servo, the E here is simply our voltage. So we're passing the voltage that we receive into the servo service. This service, when we create it, again, we passed in the I2C bus. All we're going to do is create a PCA 9685. That is that controller for the PWMs. And then we can wire up as many servos as we want, obviously up to the 16 that it supports. This is an MS-24. The Meadow.Foundation library has several by part number servos defined, and if you have a servo that is not defined in there, you can create just a generic angular servo and give it some of the characteristics such as the pulse width and the sweep angle for the servo. Next, if we take a look, again, we have this rotate to when the X value changes, which is this. All we're going to do is figure out what the midpoint, so the mid voltage is 3.3 divided by 2 because the joystick is just a divider. We determine if we're above or below the midpoint, which will tell us whether we're pushed to the right or to the left. And then we just calculate a percentage, how much of the direction to the left or the right that we have been pushed. And then we scale that to the percentage of the angle. So if we're going to the right, if we have the joystick at, say, 25% to the right, we want to move to 25% of the maximum angle for the servo, 0 being in the middle. And then the same thing for going left. Again, once we have all of that wired up, this gives us, say, 50% to the right, gives us half of the motion to the right. Full right gives us full sweep to the right. And again, same thing to the left. That's it. It's really, really simple. Just wanted to quickly show you how you can integrate inputs to servo outputs using a YoshiPi and the Meadow framework. Thanks for watching.